Energy recovery ventilator. What is it? Where is it located? Let's talk about it. Energy recovery ventilator is bringing in outside air into the building and exhausting used air in the building, running it across an enthalpy core, which helps temper the incoming air to serve the space. In order to get the correct air changes per hour, fresh air has to be brought into the building. So what an energy recovery ventilator does is it takes that used air and it helps treat it. So it's for efficiency. This model is a rooftop unit. So it sits on a roof curb on top of the building. Let's get into the main parts of it and then we'll get into the details. So this unit has an outside air hood here. You have your outside air damper. You have your supply air filter. This is your enthalpy core. This is where the two air streams cross one another. Now they don't contaminate each other, but they're across that core, they do absorb or reject heat depending on how you want to look at it. But this airstream comes out through here and comes across the core. So here's our core. We have exhaust filters here. This is our return air damper. So that fresh air comes across the core and goes and serves the space. When it's used in the space, it comes back up this return across the core. We have an exhaust fan chamber here, which exhausts that used air to the outside. We also have a supply air fan here that's pulling that outside air in to serve the space. There's also an exhaust hood. And then I did put over here, which we'll get into later on, is the electrical components on the front face of this ERV. They cover up these two chambers. So I didn't want to cover up these so that we could talk about them, but I put this panel off to the side here, so we'll talk about it later. So we've talked about how it works, but now I will talk about the controls of what goes into making it operate properly. So on the control portion of this, there are points in several spaces that I have here in circles with numbers. So we have a legend over here. This legend here shows all the points that are within that system in order for it to be controlled properly. So obviously we got the 15 points here. So what I did is I reflected where they go within the ERV itself. So I'll start here at the top. Number 10 is our outside air damper. So that's going to be a control point that, well, all right. Let me pull in where the electronics are to this. The DDC controller controls this whole unit, okay? So we first need to provide power from within the building up to this panel. So that power goes to a disconnect with a ground. Then that power here branches off to a transformer, brings it down to 24 volts, which goes to the DDC controller. And it also powers the two VFDs. So we have a VFD for our exhaust and a VFD for our supply. So that VFD is adjusting that fan speed as required. So that wiring there goes over to the supply fan. and same for the exhaust. So all these points that I have shown here, they all get back to the controller. The controller then takes that information and based on set points, adjusts accordingly. So for number 10, we've got an outside air damper. That point will go back to the controller. So that will open and close to allow fresh air, fresh outside air in. Point 8 is going to be our filter switch, which is going to show, what the difference is on each side of the filter so that you know when you need to replace those filters. On the exhaust filter, you have the same thing. You have another point on each side of that filter so that you're aware of when those need to be replaced. Point 9 is your return air damper. That obviously opens and closes as the unit runs. Point 1, 2, and 3 here are your fan speed, start and stop operation, and its status. 4, 5, and 6 are the same just for the supply fan. So you got your fan speed, start and stop, and then your status. All right, number 15 is our return air temperature sensor. Number 12 is our supply air temperature sensor. Number 13 is our ERV hot water control valve. So in the wintertime, when you really need to temper that outside air before it hits the space, they utilize a glycol system within the building that's connected to some boilers, which helps get the supply air temperature regulated. And then we have point number 14 down here, which is our supply air temperature to the fan coils. So that point will be coming downstream in the ductwork where it's serving the fan coil units. So that controller is taking all that information all at the same time and sending that signal back to the master panel on the building management system so that the facilities team can monitor what's happening with it and can make adjustments as fit. I'm going to quick show the winter versus summer performance chart because I thought it was pretty cool to see how this unit runs depending on the extremes of each time of year that we have here. So this is our winter performance. So this is taking a 0-degree temperature. So this is our outside air coming through our core. So our outside air is 0. Our indoor air that we're exhausting is 68. And our supply air leaving is 46. And our exhaust air leaving is 17. So I think that's really pretty cool how we can get 0-degree air across a coil. And on the other side of it, we can get 46 degrees. Go from 0 to 46, just passing through that with the leaving air temperature. That's pretty awesome. All right, then going for our summer performance, you got a 90-degree outdoor temperature. We got 72 indoor that's been treated by our fan coil units. And we take that 90, run it across 72-degree air, and we can get that knocked down to 77 degrees. So I think the winter performance is incredible how drastic that is. but nevertheless, it's still pretty impressive to bring 90-degree temperature down like that as well. But I just thought it was interesting to show the performance of the core and how critical it is to have something like this on a large building when you're pulling in that outside air to get it tempered. So anyhow, if this video you found value in it, I'd appreciate sharing or subscribing. If you have any other questions related to energy recovery, please let me know. I'd be glad to help you out. Thanks.